Welcome to Hartman Math. This is lesson 6.7, log graphs. So let's have some graph paper handy. We're going to take a look at example number 1, which says graph f of x equals 2 to the power of x and g of x equals log base 2 of x. So we're going to start with this one. This is our exponential function from earlier in this unit, where once we realize the pattern for the exponential function, we're going to do a mini table of values where we pick 0 and 1 for the x's. So if we substitute those in, 2 to the 0 power, that's the 0 exponent property, that's 1. And then 2 to the first power is 2. And if we remember for our exponential, they take off low, kind of like an airplane taking off like this. Military really taking off and going up. Gets close to but does not touch the x-axis. There we are. And then earlier in this unit we also learned about log functions, that they are the inverse of exponential functions. And when we were talking about inverse functions, we also noticed that they were reflections, in terms of graphs, reflections of each other in the diagonal line y equals x. And part of that process was to switch the x and the y. So notice what we're doing is we're switching these, and then that would reflect across this diagonal line right there. Reflects that point, and then the graph bends like this, so that you can see they're mirror images of each other in the line y equals x. We're going to look at a few more things about these, and then we'll just kind of generalize so that we don't actually, if we want to graph the log graph, we don't have to graph the exponential first. So we'll see some shortcuts on that. But before we do, let's see some characteristics of both of these graphs. Starting with our exponential, what's the domain? Forever left, forever right, all real numbers. The range, everything is above 0. The asymptote, we get close to the horizontal line, y equals 0. Horizontal line's y equals 0. All right, for our log graph, the domain, it doesn't actually go forever to the left. As you can see, we're getting closer and closer, but we're not going to touch the y-axis. So everything's to the right of the y-axis. All of the x's are greater than 0. The range does go forever down, does go forever up. So that's all real numbers. And then the asymptote, we're getting close to the y-axis. So that's the vertical line, x equals, passes through 0, x equals 0. So in terms of our exponential, you can see there's a connection between range and asymptote. But in the log graph, there's a connection between domain and asymptote. So in general, we'll just ignore that that's there. If we're trying to graph a base log graph, that is just log base some number of x. That's our base function for the log function. Here are our steps so that we don't have to actually graph 4 to the power of x first. Step number 1. Plot the point 1, 0. Because log base anything of 1 will always be 0. Step 2. Plot the point base, 1. For this problem, our base is 4, so we'll do 4, 1. Ooh, there it is. Because log base 4 of 4, 4 to what power is 4? 1. So those are our two key points for the log graph. 1, 0, base, 1, or the base graph. Now we're going to go ahead and draw the curve that passes through these, that gets close to but does not touch the y-axis. Because the asymptote is the y-axis. So our domain, again, everything to the right of 0. X is greater than 0. Range, down forever. Now, it's going to go up pretty slowly as we kind of trend out this way, but it is going up forever. And then our asymptote, vertical line, x equals 0. Example number 3, let's graph a log graph with some transformations. Start with base graph first, stops at the x. So we're going to graph that one first, log base 3 of x. So remember our key points. 1, 0. Base, 1. Since our base is 3, 3, 1 is going to be the second point. Draw the curve. Since it's a base graph, it's going to be dotted. It's going to get close to but not touch the y-axis. Now let's shift everything inside parentheses. Think opposite. Right to. What you see is what you get. Up 1. So we're going to take our key points, right to up 1. Oh, we already got one there. That one's going to go right to up 1. Now we got the asymptote, it's also going to move. So we've got this vertical line, it's going to go right to up 1. The up 1 doesn't really change anything since our vertical line goes up and down forever, but the right to is important. We're going to redraw our asymptote right to. So now let's get close to our asymptote, pass through these points. There's our graph, probably needs an arrow right there. It's going off the edge. There's our graph. Domain. This time everything is to the right of 2. X is greater than 2. The range isn't going to change. All these log graphs are going to go down forever. They're going to go up forever. That's all real numbers. And the asymptote, vertical line, passing through 2, x equals 2. All right, go ahead and pause the video here. Try this one. Start with base graph. Get to your final graph. See how it goes. All right, our base graph stops at the x. Log base 5 of x, so we've got 1, 0. Base, 1 would be 5, 1. The bigger that base is, the harder it is to draw because it tends to want to go flat, but it's got to keep going up. It can only bend in one direction, so something like that. And then what are we going to do? We're going to shift inside parentheses, think opposite, left 3, nothing out here. So just left 3, left 3, left 3. Let's redraw the asymptote. It was here, so we're going to go 3 left, 1, 2, 3. And draw the curve. It's tough. Make sure it's still going up there. I didn't say it, but let's see if we can go through and think of what's the domain. All of our points, our curve, everything is to the right of -3. So x is greater than -3. The range, all real numbers. And the asymptote, vertical line, x equals -3. That's it for today. I'll see you next time.